Good morning, everyone. It's Friday. The year is getting to an end, and we're super excited today in the sixth module of HSBC Metabase Q Talks Executive Program. We're super excited to have the conversation today around industrial technologies. I think it's one of the big topics and things that are coming from an attacker perspective, and we're very fortunate to have Jory Van Antwerp. I know I pronounced it wrong, but I did my best on it. Amazing background from Jory. He's worked in some of the largest companies in the world around cybersecurity, very focused on OT devices. He founded a company called SynSaver now, and has tons and tons of experience on how to protect the industrial companies from getting attacked. And on the other hand, we have Salvador Mendoza, who's the head of research and development and part of the Oslo team from Metabase Q. Tons of research that he's been doing over the past few years. Great speaker on Black Hat, DEF CON, and many other ones, where he's also an expert on processing, but has a lot of background as well on the OT side. So I think it's going to be a super interesting conversation. And before we start and we pass it on to them, Carlos, I pass it on to you. And again, thank you for co-hosting this with us. And we're looking forward to providing a lot of insights to the customers.
No, thank you, Mauricio. And thank you, Salvador and Jory, for joining us. This is a quite important and relevant topic to discuss. So let's tackle it. And thank you for everyone that has joined us today.
Thank you.
Chava.
Thank you. Good morning.
Go ahead.
Thank you. It's really a pleasure, and I think this panel will be very interesting to talk about industrial environments. And today, we're going to have a very special talk about different topics that's going to be very, very interesting. We have an agenda for today, so I'm going to explain a little bit about what is going to be the topics. Basically, we're going to start talking about what is an environment or industrial environment. Also, what are the most OT environments, why they're breached in the last decade, for example. What are the more significant difference between IT and OT technologies? Also, we're going to talk about the threat intelligence in the OT environments. Finally, we're going to talk about regulations, vulnerabilities, and patching, one of the main things about these technologies, and how these IT and OT are converging together during the last few years, and how they're going to be the future for these technologies. And finally, we're going to have some conclusions. Why is important this topic? Basically, because we are seeing the last decade many different attacks against different companies. We have seen different attacks against water utilities, smart meters, petrochemical plants, water treatments. And according to the University of Oxford, he mentioned that if a cyber attack it's successful in one of these plants, the loss per day, it's 120 million approximately. So it's a very big number. Now, many of the main things about these attacks is the loss of utility service at scale, human health and safety, of course, and financial loss is one of the main things. But we need to think about how the environment damage that we can create with these type of attacks against these technologies. I want to give the word to Jory to explain a little bit what is this industrial environments, how they are designed, and how we can draw an image in our brain to see how they are designed.
Sure. So industrial environments are a little unique when we think about traditional IT systems. Traditional IT systems tend to have a lot of components that are the same. Every environment has an email server, they have a file server, they have an authentication server, etc. When it comes to industrial environments, it doesn't matter if it's power, if it's water, if it's water treatment, or if it's even an Amazon fulfillment center. They're all run by very similar devices. However, how those devices are put together into a solution is what makes them very unique. The devices themselves are meant to be robust, and they manage to be robust through being simple. And what this means is that they don't have traditional operating systems, at least 90+% of the devices don't. They have what are called real-time operating systems, which means it's basically just a network stack. We're not seeing Windows, it's not Linux, it's not Mac. It's usually VxWorks is the name of the real-time operating system that's most often seen. This means that by design, this has no encryption. There's no authentication. There's no security built in to begin with. To kind of add to this is the fact that each one of these environments is unique in how they're created. So we'll pick on power because they're probably the most unique. If I'm designing a facility to generate power for subscribers in an area, I'm going to give a square footage, how many subscribers I have, and what my kilowatt output has to be to several different vendors. Could be Schneider, Siemens, GE, just as an example. They're going to bid a solution to produce that for me. And that solution is all encompassing. It is the generator itself, how it hooks into transmission, every single device down the wire, including the machines that run it, and how it's going to hook into the grid. And it's designed to fit into the space available to them. And what this means is that it makes almost every single one of these industrial environments a little bit like a snowflake. They're all unique, which means they're a little bit more difficult to attack, but it also means they're more difficult to defend. Because these solutions are put together all encompassing, everything that is included in that solution is meant to be supported for anywhere from 20 to 40 years. And this is where you hear those horror stories of, I have a machine that has Windows NT because it's 25 years old. And that can happen. And the reason being is that because it's a unique thing, you can imagine from the vendor perspective, if they have done 10,000 of these, they cannot test every single patch in every single environment to make sure that they'll stay up. So in many instances, they're simply just the way they were when they were actually installed. No patches, no upgrades, no firmware updates. It has to be a real issue for a vendor to reach out and do that. And that means it's a little bit harder for us to defend them.
I think one of the main points is that because we have many different brands selling these products, and also we have a lot of legacy devices in the environment. We have this problem that we have many different protocols also inside of the industrial side. Many people talk about Modbus, TCP, Bypass, BACnet, many different protocols that it's going to be very difficult to protect because there are many different reasons or commands that is traveling through the network, which is very, very, very difficult. As you mentioned, Yori, one of the main things about how these kind of environments could be breached implementing this type of technologies, because it could be that they are legacy, or probably they don't have the talent people or the technology to protect in the correct way, on the methodologies to protect the correct way. What do you think is the most important, and why these plants or companies are breached in the industrial environments?
That's actually a really interesting discussion. So these environments themselves suffer from being extremely accessible. Physical security is key. If we're talking about a power substation or a water pumping plant or even an oil derrick, if I was to go and use bolt cutters and simply shear the chain link in the fence, go inside and plug in my laptop, I don't need a vulnerability to do anything. At that point, I'm able to change configurations on any device. Remember, there's no passwords, no encryption, there's no nothing. As long as I don't take that particular facility down, let's say it's an oil derrick, the monitoring team isn't going to know what's going on inside that environment. And so what we find to be the most important thing that's needed inside OT is visibility first and foremost, and visibility all the way out to the edge, which is what we call substations or pumping plant or pumping stations, as well as oil derricks and pipelines. But visibility is key, and understanding what assets are in that environment is another piece. The visibility has to be down at the edge as well, and this is something that you actually started to cover with your protocol discussion. There are unique protocols inside these environments, and those protocols, because they're meant to be secular, are down at the edge. So 99% of the traffic, 99% of the operation happens at that particular site. It's not going back to a data center. It's not going higher up in the chain, which means that if you were to say monitor from a centralized location, you're only going to see 1 to 2% of the traffic, which means your visibility is very, very, very low. So actually having visibility at the operation itself is key into first understanding what's in that environment.
Do you think this visibility needs to start from the inside out, basically, to have all that kind of all the information traveling around the network? because what I'm seeing in many different aspects is like we start worrying about what are the devices that we have in the environment, but we need to think about the visibility that a specific model to start seeing things that probably in the last few years we didn't see it before, like what are the packages that are traveling, how they are traveling, is something that is injected or something like that that we can see in the SCADA models. This give an example about how we can relate the OT technology with the IT technology, how they differ between each other, which is, I think, it's one of the most important things to understand how these environments are different, because many people, for example, we know a few things about IT cybersecurity, but there are many different aspects or concepts or methodologies in the OT world that we don't know.
That's very true. I think we have to start at the highest level, which is how we think about these systems. In an IT environment, we're very concerned about security and uptime. You hear 5 nines, and cybersecurity is everywhere. But the way that we can interact with these systems is a little bit more verbose, meaning we can block, we can install agents, we can have multi-layered security throughout an environment that can proactively stop an attack. And in many cases, if there is, let's say we'll say a false positive or even a false negative, the ramifications are rather low. So if we have a false positive and a file is blocked, a system administrator is called. System administrator may release the file or fix the issue. But the focus is on keeping that data flowing, but doing it in a protected manner. If we shift to an OT environment, this completely changes. Instead of being focused on uptime and cybersecurity, they're focused on reliability, efficiency, and safety. Those are the three. It doesn't matter where it's at. And safety, I should say first, always comes first, the safety of the actual operators at that particular environment. Because of this change in focus, and because you're no longer dealing with digital systems, when we talk about these devices, they're controlling physical assets. And those physical assets could have the capability of harming or even killing operators if they're not running correctly. Well, that means in many cases, we can't block, we can't be proactive. We cannot go to the level that we can in IT, which means we have to pay a lot more attention from a visibility perspective. If we were to block traffic and have a false positive, for example, let's say that false positive blocks a safety system. That safety system was in charge of making sure a tank didn't overpressurize. We could have an explosion. And that's just by active blocking with one false positive. So in these environments, it's almost impossible, outside of very specific industries like advanced manufacturing is one, and pharmaceuticals, to actively block. We must be passive, and we must be very, very good at identifying things passively.
So, for example, I was thinking that we have these kind of methods that we implement, like protocol visibility. That could be one of the things. Asset identification, it's one of the another things that are very, very important. Intrusion detection and prevention, that could be another step. Probably we don't talk about malware sandboxing. That probably could be in the future in the threat intelligence topic. How we can go from the way that we are in this specific step, how we can go to a threat intelligence in IoT, which is going to be, I think, one of the main specific topics that we have to discuss, because we can see many threat intelligence, even the IT is sometimes very difficult to approach, but how we can start thinking about the threat intelligence in the OT environments, that could be very crucial.
So you actually just wrote a map to how you would actually provide visibility in OT environments. I want to comment on that first. If you can't understand the protocols, which as Salvador mentioned earlier, are mostly proprietary in themselves. If you can't dissect them and fully dissect them to understand, it's very difficult to get any visibility whatsoever. So first comes that dissection and then identifying those assets. The assets themselves, it's not just understanding that an asset is a particular type of asset and it's running, firmware X. It's actually understanding how that asset fits into the operation and what other assets it's talking to. So almost building a fingerprint or a profile around that asset before you can begin detecting in that environment. To flip over to the question of threat intelligence, it's a difficult one in these environments. Going back to the some of my previous comments, because these environments are so different, it's not like an IT environment where threat intelligence can be used day to day, meaning a new attack comes out. It could be Log4j, for example, or we could go back and do Aurora was another attack that hit multiple companies because the companies have those similar infrastructures, meaning they have that authentication server, that email server. They may even be using open source protocols or open source software, which is where Log4j came from. And it means that with a single exploit, it's easy to hit thousands, if not tens of thousands or hundreds of thousands of companies. In the idea of threat intelligence in OT, the first thing that we need to understand is real OT attacks. And so I think a good way to put this is there's only really been 3 industrial attacks that we know of. It's a big one we know of due to lack of visibility, which is Stuxnet, Indestroyer, which is also known as Crash Override, and Triton, which is also known as Trisys. But those 3 were actual attacks against industrial control systems. So they were attacks against PLCs or RTUs, which are programmable logic controllers or remote telemetry units. Same thing, just different vernacular in different organizations. Those attacks actually, I would say, didn't really exploit, but they were meant to be in an OT environment, and they were meant to do very specific things. The very interesting thing about these particular attacks, I'm sure everyone's heard of Stuxnet or Crash Override, is Stuxnet only worked at 2 locations in the entire world. Crash Override's the exact same way. Can we learn about some of the tactics that were used? Absolutely. But when we look at the tools and the procedures that were used internal to that, you can't reuse them anywhere else because these environments are so different. So understanding threat intelligence in OT is still applicable. Seeing what's being attacked, what verticals are being attacked, who is targeting those particular verticals, how they are being approached is very, very important. When we talk specifically about industrial, it's very difficult to use that day to day. So threat intelligence, I would say, I want to change that to be operator intelligence. We need to actually empower our operators and our analysts that are in these plants to be able to codify the knowledge they have of their specific solution into the platform and detect using that.
I had the opportunity, somebody asked me a question the other day about how we can automatize the threat intelligence in the OT environments. But because we don't have too much information about these attacks, it could be very, very difficult to do something like machine learning or put some neural networks to do the job. I think that's one of the main aspects in this type of threat intelligence automatization blocks that we have at the moment. So, Jory, you mentioned this type of different type of protocols, different type of environments in the industrial. How the regulation applies for this type of environments? That could be very crucial to know a little bit more about that.
So I will have to apologize. My best examples are ones that are specific to the United States, which is NIST, NERC CIP, and IEC 62443 are the 4 main compliance and regulatory. What's interesting is each one of these is actually very similar in how they're approaching the environment, which is they're looking for full visibility and monitoring. And most of the audit or regulations are around those particular assets. Is an asset physically there, and is it speaking? Has it changed configuration recently? Have we had any new assets that have come into the environment? And how are we logging and reporting those assets? Those are pretty much the common thread between whether it's NERC CIP, NIST, or IEC.
I want to take some of your ideas from the beginning about the visibility that I was thinking about it. Can you mention a little bit how we can design something with more visibility? I know we have this kind of PLCs or this kind of devices or sensors that we use to get data, and they are kind of all technology that we don't have that possibility to get this kind of information. I know that probably you guys have some kind of tools that we can implement for this kind of visibility and this type, or change these kind of sensors to get more visibility in the network. How that specifically works? Is like a passive devices or something like that?
Yes, actually, so SynSaber is taking a very different approach to the market, and it was specifically to meet these needs. What we're finding is in these environments, they are very, very static, meaning maintenance cycles or even hardware refreshes. Hardware refreshes could be 25 years. Maintenance cycles could be once every 3 years because of the uptime required in an environment. So it's hard to physically change devices in these environments. And as you said, passive, or as I should say, we both talked about earlier, passive is really important. So the approach that we've taken is to actually provide a network sensor similar to what you would think of as a network detection system or a intrusion detection system in IT. And we've made that pure software. And what we've tried to do is make it as flexible as possible. I call it vendor agnostic. We do that in 2 ways. One, I want the organization or the client to be able to utilize their existing infrastructure. So if they already have devices down at the edge, I want to be so small and so performant that I can actually install that sensor on one of those devices. We could sideload it. We could drop a binary directly on it. It could be a container. It could be virtual. But to utilize the hardware that's already there, and that requires a very small footprint, which is something that we do. Agent tends to be a bad word in OT, but it is more like an agent than it is a network sensor. The second way is that the way that we've designed the software is to be what we call headless. There is a management console, but that is just to deploy new sensors or manage your sensors, upload your, codify your operator intelligence, codify your threat intelligence that you may be getting from places like CISA, et cetera, and load those out into your environment. Outside of that, everything should go to what you're already using today. It should be your SIM, your SOAR, your ticketing system, which could be ServiceNow. It could be your alarm management system like Emerson Ovation, for example, or even your Pi Historian. But that's how we're approaching it, is to try and make it as easy as possible to integrate completely into the workflows that already exist today.
Basically, we have the initial step, which is the visibility. I think that's the main important part. And after that, we start thinking about how in the OT environment we have the vulnerabilities and patching process to do it. Probably you mentioned a little bit earlier about different things about the legacy stuff and the operating systems, but how you guys, or how you see it in the market, how this is approached?
So this is something I'm extremely passionate about. So if I get on my soapbox, you get me off of it.
Yeah.
So from a vulnerability and patching stance, it's very different. As I said before, it has to be approved by support, and that's coming from the vendor. So if the vendor says that a patch doesn't exist or that you cannot install, for instance, if you have an HMI, which is a human machine interface, it's basically a workstation. If it has Windows, you can't install a Windows patch without an approval from the vendor. This makes things kind of difficult because vulnerabilities need to be reported and measured in a different way. We have severities on the IT side, and let's say it's a severity, it's a critical patch, right? It's a CVE with a critical score. We've got a possible exploit that could really do some damage. Well, in an IT environment, it may be applicable to have a critical score. In an OT environment, it may not be applicable at all. And one of the ways that I can kind of break that down for you is, if you have an exploit and it requires physical access, meaning you have to either plug in a USB or you have to do something physically, it's game over. If I have physical access to an OT environment, I don't need an exploit. Remember, there's no authentication. I can change anything I want in that environment. So is that critical in an OT environment? It is, but I don't need the exploit. What's critical in this particular instance is the physical security of that environment and knowing whether someone has actually entered that substation, that pumping station, or that pipeline, and actually done a change. If we have that visibility, we can do quite a bit, but the severity of that patch changes because, again, if you have physical access, it's game over. Vulnerabilities are a little different in OT because of that. And we need to take a look at something that we've coined a term at SynSaver. We call it Forever Day. And those are vulnerabilities that can never be or will never be patched inside of OT. And some of these, for example, there was a report that came out from a vendor that will remain nameless called OT Icefall. In an OT Icefall, they actually created a vulnerability, a CVE report for Modbus. Modbus does not have authentication. That's by design. They would have to rewrite the entire protocol. This is a protocol that over 60% of all devices use. It's not patchable. It's not fixable. That's just bad reporting. You should never report a vulnerability that you can't actually fix. And this is something we see a lot inside the OT space. What I do think is incredibly important, to go back to vulnerability and patching as a whole, is being able to properly set the criticality of these CVEs, these vulnerabilities and the exploits, understanding how those exploits have to be completed in an environment, so that we can set up a risk model for these OT facilities, so they can understand exactly what they need to take action on, or what may actually be a forever day. It may be something that, yes, we need to know, we need knowledge of it, we can detect it, but do we need to go and patch it? Not necessarily in these particular environments. I hope that answered your question.
Yeah, I think one of the most new firewalls in the next generation, they call it, is not only that they can filter application and protocol, but also the flow, basically the commands they can send through the network, that probably you can make some rules to detect that is specific, that you cannot stop the pump specifically, let's say, or you cannot start that specific PLC or whatever. So all these new firewalls that have this specific technology that we are seeing in the market, I think that could be a very good opportunity to change somehow this specific vulnerability path that we already have. This we can take this one to the next conversation topic, which is basically how we converge between IT and OT technologies in this environmental, because we are going to see in this in the next years. I mean, we are seeing in some examples, actual examples, but how we are going to see this converge between IT and OT in the future.
So OT and IT convergence is an interesting topic, because I'm going to show my age. Having been in the business for this long, we've been talking about OT and IT convergence for nearly 15 years. In most environments, it's done. They're converged. And what that means is that the OT environment is connected. It may be through a DMZ, it may be through a firewall, but it is connected with the internal IT department. And that's how they tend to monitor things, or backhaul data back and forth is actually across that IT network. And because of that, it increases the level of exposure. So that convergence and why it's really important to understand is that IT systems can be the point at which a breach starts, or IT systems that are converged, let's say monitoring. So you have monitoring in an environment. We'll use Colonial Pipeline as an example. When Colonial Pipeline was hacked, that wasn't actually an industrial hack. No OT systems at all were breached. It wasn't even the target. What was actually breached were the IT jump boxes. What a jump box is there's a DMZ between IT and OT. You'll have to remote into a server. From that server, that jump box, you can then reach the OT environment. It's meant as a security precaution, a centralized place, a single point of presence to stop people from actually walking across that convergence easily. Well, the problem with that is that was the particular system that was attacked. So that system was locked up, and therefore they had no visibility into OT. So if the pipeline, for example, would have been overpressurized and we had a huge oil spill, they would never have known, which is why the pipeline was shut down, was specifically for, again, it goes back to safety, efficiency, and reliability. But that convergence is where we see a lot of issues on two fronts. One, things can happen by splash damage. You have ransomware that's running rampant, and if you don't have a good barrier between your IT and your OT, like that DMZ, you could very easily end up with human-machine interfaces, or HMIs, that are ransomwared as well, that are going to stop an operation. On the other side, we have what I think is even more, I'll say scary personally, which is we have attackers, whether they're nation state or frankly just organized crime or even anarchists, that are starting to try and understand critical infrastructure. The best way to do that is to land in the IT environment and start gaining reconnaissance, going out and getting intelligence on how that OT environment works. That reconnaissance style approach in malware is something that we see easily 75% of the time. And that is frightening to me, because with that exposure, that's how we're going to start seeing more crash overrides, more Stuxnets, because they're going to understand the environment they want to attack.
So basically, I see another problem at this point, how the IT guys and the OT guys are going to work together, because we have different methodologies, different knowledge, different environments, that probably we can grab some terminology or topics from IT and basically seeing in the OT, but many methodologies and the ways that we work, there are many different. How do you think we can have talent in both ways, in IT and OT, that they can work together? And what is the best way, let's say, for training people from the IT to work in the OT, or to OT to work in the IT? Because we need a bridge between these two teams as well.
I could not agree more. And I would start actually, we have tended to do workshops both at SynSaber and at previous organizations I've worked with, that actually talk about those differences in safety, reliability, and efficiency, and why that's important to OT, and the physical effects that can happen from a mistake, not even a hack, just a human error in a process, and how that can affect things, whether it's taking power out to a microgrid or causing other issues. And I think that's the first place to start, is to actually set the stakes. We're not defending digital systems that we can reboot. You know, you take down a generator and it takes 4 hours to get it back up and connected to the grid. So there's a little bit more, I don't want to call it criticality or importance, but there's definitely needs to be more thoughtful. I think the other area, and one of the things that we aim to do here at SynSaber, is to give them a universal language in order to speak. And Salvador, you nailed it. The fact is, you have security analysts that are very comfortable writing Python script, looking at packet captures, looking at security events. And if you went to the operator at a generation facility or the operator at a water treatment plant, they may not even understand what an IP address is, right? This is a physical process engineer. They understand zeros and ones and how it's on off, right? It's electrical engineering more than it is anything that we're familiar with on the cybersecurity side. And because of that, we've seen a lot of issues where IT will come to the OT personnel, for example, and say, we have a problem with this device, and they will list the IP address. The operator has no way to even look that up. They don't know what that device is. So I think one of the things that we could do really as a marketplace is start identifying those assets and putting them in a centralized place that links the two, so that IP address X is PLC, programmable logic controller, Y in pumping station F, and an IT person can literally go to an OT individual and say, hey, we're seeing some anomalies in this pumping station with this PLC. And that will start a conversation. Also, educating IT on how maintenance cycles work, how hardware refreshes work, and how support works inside OT is very, very important. It's something that honestly I try to do every day, and every time we have a conversation. Maintenance windows are incredibly important. Can't do anything outside of them inside of an OT environment. You can change nothing. Software, hardware, doesn't matter. When we talk about how important efficiency and reliability is and uptime is in those environments, it begins to ease things. So if an IT individual actually comes into the industrial side of the house and says, I would love to work with you to understand your environment better in your next maintenance window, instantly the operator understands that the analyst, he gets it, or she gets it. Understanding what that maintenance window is and why it's important and how they can't mess with the operation outside of it is key. So education is the biggest piece, to put it shortly, is to educate each side that cybersecurity is important, and cybersecurity is more than just the operation. But at the same time, from an IT side, the operation is very different, and it is very important. There's very real physical ramifications to issues that we see there.
I really love the common language between IT and OT. I think that's one of the main keys in these environments. I think we're in good time, Jory, to go to the conclusions about this industrial topic, which is very, very interesting. And I think it's very good. We have a lot of opportunities to learn, but also to protect these environments. I was thinking about, I have some ideas. As you mentioned, we have the visibility in the beginning. I think that's one of the keys. Asset identification, that could be the next step. Intrusion detection and prevention, that could be in different ways, as you mentioned. And threat intelligence, that could be a final step that could be very, very critical in the future. Or we have more information about this type of attacks, could be more automation for the ML or artificial intelligence. So what are your conclusions, Jory, about what is the future for these industrial environments and how we can protect them, how we can help people to do the best jobs?
So from a market stance, we're doing that in many different ways. There's a term called Industrial 4.0, which is starting to take some of these PLCs and RTUs and put traditional operating systems on it with built-in security and encryption, and starting to really move towards the next level. That's the first, is that future, that forward thinking. How are we going to secure these environments and make sure that they're safe? And Industrial 4.0 really is starting to do that. We're seeing those devices hitting the market in the last 3 or 4 years. But more so, as I stated in the beginning, these solutions could be built for 20 to 40 years. So getting to that hardware fresh, being able to install an actual Industry 4.0 device, one, they have to have the budget. Two, it has to be in the next refresh cycle. So it could be 15 years, it could be 25 years. So one of the most important things we can do today is to realize that we can't change those environments quickly. It's just not a possibility, one, from complexity, and two, from cost alone. I mean, if you installed Industrial 4.0 devices at the power company that powers my home city, it would be probably close to $1 billion. And that would be passed on to individuals like myself, paying to keep the lights on. So we need to meet them where they are today. We need to do everything we can to secure the environments as they are today. We need to make it easy for them to gain visibility, to see that asset identification, and to actually provide, I'll say, curated or normalized data outbound that's easy for them to understand, so that they can secure what they have. And then as we move forward into Industry 4.0, that's where things change, and we can really look towards the future. But again, that could be 20 or 25 years. So how do we help them today? That's what's really important. And stop telling them how to change their environment, right? Or how they need to upgrade, and start talking about, how can I help you? What is the minimum that I can do for you right now?
Perfect. Thank you, Jory. I think we have a few questions. Let me see if we can grab them from here. Yes. There is a few questions. Probably we can answer some of them. I think we have enough time.
Sure.
Let me start with how should manufacturing companies begin their cybersecurity journeys in OT, and what framework or process should they follow as a guide? Basically, the idea is, any recommendations for the beginning of these companies to get in more in the cybersecurity aspects? So
there is a framework, a reference model that we use in OT called the Purdue model. The Purdue model is not a process flow, but is a reference model for how to separate each layer of your environment. It goes 0 through 5, but as an example, your physical devices, the relays, the pumps, switches, valves, those are all on layer 0. And then the PLCs that control those are on layer 1. And those above that are the HMI, how we actually interact with that process. And those are separate, meaning they're firewalled off and DMZ'd from the rest of the environment. Then it goes into your control centers, and then your DMZs, that is where the convergence happens between OT and IT. Those again are firewalled. But the Purdue model is a fantastic place to start as a framework for how you can start segmenting your networks, because network segmentation is key at this point. If we can't secure the device, if we can't secure the protocol, then we need to physically or at least digitally segment and physically secure those devices. So that Purdue model is one of the best places to start. Another area that I would say is the next step, or even can be done before the Purdue model, is understanding what you have in your environment today. So if you don't have an up-to-date asset inventory, one of the greatest things that you could do is actually have someone come in and do an architecture review and assessment. And those they can be done by specialists at Metabase Q, for example, that will come in and deploy technology that will identify your assets, help you build an inventory, and then understand how those assets are talking so that you can implement the Purdue model segmentation and make sure that your environment's secured. Those are the two best things that you can do walking in. Past that, monitoring, meaning visibility.
Yeah, of course.
You can't defend what you can't see.
Exactly. Thank you, Jory. I got another question. Now that we have the 5G and will be used on the OT for environments, do you see any attack indirectly implementing this technology or attack surface in the environment of, let's say, industrial environments?
It definitely, depending on how it's deployed. So 5G devices tend to be IoT devices. And actually, that's something we didn't cover. IoT is very different than OT. And you don't have IoT devices in OT. They're on separate networks. But with a 5G modem of some kind, or even an appliance, usually those are IoT, which means it may have more vulnerabilities and may be an access point. So the way that we see today 4G and 5G devices installed is usually on the outside of a firewall around a DMZ. And it's very specific on what can be allowed inbound and outbound, and it's just monitoring data, meaning the 5G itself has no access to the process as a whole, just visibility.
Great. Thank you, Jory. We have another last question. Do you have any insights on the almost successful attack on the Florida water plant attack? Was it directly to OT or not? Do you know anything of IT?
I do. That was IT focused. So a lot of what we see is falls into what you might call shadow IT. Colonial Pipeline is a good one. Florida is another. Even I'm going to forget the name. There was one recently in the UK at another water facility. Staffordshire, I think is the name of it. Those were all breaches into the IT environment that then were able to pivot into the OT environment because it wasn't properly segmented. So no hack was executed in the OT environment. It all came in through the IT side. And in the case of the Florida, that one was very interesting because what we saw as leaks and what we saw come out was all reference architecture and data, which is useful to a hacker, but showed no real access to the OT environment as a whole.
Great. Perfect. Thank you. We have another last question. Can you give us some examples about security from the physical access?
From physical access?
Yes, I think that's the way it's mentioned.
So from a physical access perspective, it depends on where the location is. But what we see a lot of companies do is they of course use physical security members. Like the substation down the street from my house has a camera that's mounted. It has a fence around it with barbed wire, and it is of course padlocked. There's a big chain that blocks it. There's also alarm sensors on the door, and there is a badge reader on the door to see who comes and goes. And at this particular facility, there's also monitoring inside there. And that monitoring sees when wireless devices get too close or a new asset has come up. That's probably the best way with physical security is, of course, monitoring using both IoT devices like cameras and badge readers, and then, of course, network detection systems.
Great. Thank you. We have another question. A lot of OT environments generate a lot of data, but many times that data is not analyzed or used to take decisions. How can we change this to improve cybersecurity?
I think that's a fantastic question. I think first and foremost, they generate a lot of data, but in many situations, as Salvador mentioned earlier, that data isn't understood, meaning those custom protocols, those proprietary protocols are not understood. So one, understanding what those protocols are and how they're interacting would be very helpful. And it's I'm going to get a little bit into SynSaver, but one of the things that we do is to curate and provide human readable data to the operators themselves and to the analysts on the other side. And so we take that information and we actually, instead of saying, this function code was seen or this IP address was talking, we actually try to take the device itself. We say this PLC had its configuration changed. And here are the 3 reasons why you should care about that, right? Was this inside of, or questions you should ask, was this inside a maintenance window? Was it outside of a maintenance window? And what changed in that particular configuration, which would require interactions with your OT as a whole. But that data, when we're pulling information in, and this goes for any security product, we're pulling all that information in, and there's no reason we can't provide you business analysis as well. We have all the raw data. It's just taking the extra effort to do so.
Right. I think that's all the questions that we already have. It has been a pleasure, Yuri, to talk to you about this environment, industrial environment, cybersecurity aspects. I don't know if we have. No, we don't have any other. Yeah. Thank you, Carlos.
Perhaps, and it's been very good, all the topics discussed, expanding a little bit on how can we protect better our environments, thinking about the concept of collective defense and what steps should we take in the different ecosystems, industries to enhance, embrace this type of discussions and protection of group protection. Can you share what's your vision on this?
Sure. From my side, it has to be a multifaceted approach. There is no one product that can do all of these things. It will be a solution that's built with multiple products. First and foremost is a secured segmentation, which would be smart firewalls, as was mentioned earlier, next generation smart firewalls, as well as the monitoring is really important. And monitoring not just at a centralized point, but actually out at each one of those individual segments to understand what's happening inside that process. Taking that data back to a centralized area and applying it to the intelligence that's already being provided by a SOC or a NOC. It's the Security Operations Center or Network Operations Center. Applying that to the overall security posture of the company and understanding what the risk is in that environment is going to be key for us to take the next step.
Yes, I didn't. Yuri mentioned probably he mentioned all the key points on this, but basically having the visibility, having all the practices, the good practice that we have in the IT, how we can share information between both teams. I think have a common language between both teams is the key to grow as communities, to grow as industrial environments safely during the next years. Yeah.
And another thing to share, what is in your vision the role that the regulators, lawmakers should take on these topics, especially protecting some of the key industrial elements of a country? And where do you see that there are good examples of best practices on models that are more preventive and sharing the information between the different ecosystems?
So there are several different ways that I think I can say both the good and the bad ways that regulatory boards and governments are getting involved. One, it is incredibly important to define what is critical to a country's infrastructure. Meaning, we know power and water, right? But, what about sewage? Do we have issues with pipelines? What about supply chain? Where are you getting your food from? How are things getting into port? Most people don't know that ports, those large cranes that you see, those are all industrial systems. So defining critical infrastructure is incredibly important as a first step. And we're just beginning this here in the US. Once you understand what's inside that critical infrastructure, it's putting together policies that are in a way specific enough to demand that there is good monitoring, good hygiene, and good practices while not tying the hands of that particular industry. I'm going to give a really good example of that is actually IEC 62443. That's actually outside of federal or government control. But it is a security compliance that is very, very good. And it's the way that the framework is built is fantastic. I can then look at we have the Critical Infrastructure Initiative. It's also known as the Biden 100-day initiative here in the US. And that was one that was done so quickly and so without a lot of input from the OT side that it actually caused some hardships. So they've had to go back and re-look at how that compliance and what that regulatory looks like so that individuals in OT can actually implement it.
Thank you, Jory. And fully in agreement. I think we still have a long way to go to keep on enhancing both regulatory framework and ecosystem involvement and activity around these topics. Any final thoughts before we close?
I think from my side, really just to reiterate, you cannot defend what you can't see. And it doesn't matter if it's OT or it's IT, visibility is key. And we need to have that visibility on both sides of the spectrum due to the fact that these systems are converged.
Yeah, I think we need to have the opportunity to talk and to train and to talk in the same language, the OT and IT teams. I think that's for me, it's one of the takeaways of this specific session, and to know more about these architectural ways to have segmentations inside of the industrial. I think it's another very key points on this study.
Absolutely. Thank you, Salvador. And well, thank you both for your valuable insight and information sharing. Brilliant topics, brilliant talk, and on a very, very relevant and day by day more current topic. So thank you again, Mauricio. We wanna make the closing.
Yeah, no, thank you again. It was super insightful. Thank you, Jory. Thank you, Salvador, for sharing your experience, your thoughts. And thank you, everyone, for attending the sixth session of this executive program. We're looking forward to next week's session, which is a crisis simulation. I think it's super important. It's necessary. One of the things that we need to think about is we're all going to get hacked. The question is when and how are we going to face that, right? So I think next week's session, which is on Tuesday at 10 o'clock in the morning, Mexico time, Central time, we're going to be going through an exercise to see how everybody interacts or how you should be doing the trial and making sure that you can face or what would you do in case of an attack, right? So we look forward to having you next week. Thank you, HSBC, for co-hosting this with Metabase Q. And again, thank you, Jory. Thank you, Salvador, and happy Thanksgiving to both of you.
Thank you, Mom. Thank you, Carlos.
Thank you.
Thank you for joining. See you next week. Bye-bye.
See you.
Bye-bye.
Bye now.